This mechanism we're looking at is something called a rack and pinion. So this one's got a bunch of different parts, so we'll take a look at it real quick. So obviously it's built, in this case, just on a simple base, but we've got a few different things going on here. Number one, we have a drive shaft. So this is our input or our power shaft. Okay, so the idea is that you have a motor or some form of input power attached to it. And there's a gear on that drive shaft. And that gear interfaces with this, okay? So this is our rack and pinion actual setup. And what it is it's a series of gear teeth that are designed to intermesh with this gear. And it can be any size gear you want. This just happens to be a small pinion gear. And this rack is actually mounted in a series of slides. And those slides are what's connected to the base, but the actual rack is not. It's just sort of sitting there loose. At the end of the rack are stops, and these are just designed to prevent the rack from passing through the holders and falling out. So the rack and pinion, hopefully you've recognized that word because it comes up a lot in older cars. So rack and pinion steering, in the case of a car, means that you have your steering wheel attached to the input shaft, so you'd be sitting in the car turning your steering wheel, and that would turn this gear. And on the end of this were your tires, essentially. It's a little more complicated than that, but these ended up connecting to your tires. So when you turned your steering wheel to the right, it would actually move your tires to turn to the right. Imagine these are connected to the rear edge of your wheels, so it pulls the rear edge of the right wheel in, pushes the rear edge of the left wheel out, and your entire tire would go from being straight to like this. Do the opposite, and suddenly your wheel goes from being straight to like this. So a rack and pinion is a way to, again, transfer rotational motion into linear motion. And these are really kind of neat to build and play with because you can do a lot with them. Imagine instead of it being side to side, left and right, you had it vertically and you had something up here that you needed to lift. Lower it down, lift it up, and back and forth. Again, it's a different way of creating motion from rotational energy. So you have rotational motion here going into linear motion here. Now, one thing you'll notice is that if I just hold this, nothing's happening. It's not spinning because this gear is not interfacing properly. So you want to make sure when you build a mechanism like this that your axle is firmly attached. You'd have another tower on this side, which causes it to sort of pull that gear up against the rack so that every time you turn, it makes the pinion move, makes the rack and pinion move. Now, why do we have these stops? Well, if I remove the stop and start spinning, well, what happens? It pops right off and suddenly I can't do anything because it's left the system. But this, our rack, okay, just slides right in here. You'll notice in my case, these are designed to mount on a secondary piece, but there's lots of different ways that you can actually build these and put these together. So our rack and pinion, by the way, there's your pinion, so your pinion gear and your rack, okay, again allows you to transfer rotational energy into linear energy or motion. And so it's just a different way to move things about with mechanisms.